So in this lesson we're going to be discussing transformations, and for your notes you will need your spiral notebook or a sheet of paper, and we're going to design and set up a graphic organizer of our transformations today. Set up your notebook or paper as illustrated on the slide here, and make sure that your margin with the hole punches are at the top. We're going to set this graphic organizer up landscape style, so that we'll be using the width of the paper here. The title is going to be Transformations, and then we're going to have 3 separate sections, with the left one being our reflection, and we'll have information down the column here. The middle section will be a translation, and then the right hand side will be a rotation. It's a good idea to do each in a different color, so to distinguish between the 3. We'll start out with our reflections, and if you'll notice the drawing here, we've got a solid letter F and then a shaded letter F that's reflected below this line. This line here is referred to as the line of reflection. And it is significant because with a reflection we see that the points are the same distance from each image away from that line. So if we were to truly map each point, we would see the same distance away. Something else to be said for these 3 transformations is that this first or initial figure here is referred to as the pre-image, and once it is transformed, in this case the reflection, it's referred to as the image. So again, our pre-image first, image after the transformation. We have several rules and common reflections. If we were to look at reflecting across the x-axis, and remember that the x-axis is our axis that goes horizontally. So if we start out with an initial coordinate x, y, and we reflect it across that x-axis, then the new coordinates will be that same x and then the opposite, or the negative, of y. We refer to this sign here as the opposite because if our initial point had been a negative number, then its reflected point here for this y coordinate would then be positive. So again, the opposite of y for this first reflection rule. For reflecting across the y-axis, we again start out with our coordinate x, y, and the transformed reflection will be negative, or the opposite of x, y. In our last example, we will look at y equals x, the line y equals x, and our initial pre-image coordinate x, y will then be reflected, and our image will become y, x. So we'll do more numerical examples in class tomorrow, but these are your 3 common reflection rules. For our next transformation, we'll discuss the translation. To translate simply means to slide. So we have our pre-image F here. In one example we see that it slides to the right. This is our image. And also here we've got, if we started with our pre-image F, we could slide it down and this would be our image here. So with a translation, we'll notice that all points from our initial figure will be moved the same distance in the same direction for our transformed figure. So we've got one going to the right and then a separate example moving downward here. Again, these 2 F's are congruent, or the same size, same shape. Similar to our reflection, same size, same shape for those reflected figures before. For our translation rules, we see that we'll take our initial coordinate x, y, and we will add a change to it, positive a plus a, or plus b on the y coordinate. So again, we've got x plus a and then y plus b. Each coordinate will have some sort of change to move that point around. If we specifically look at the a movement, a positive value for a will move it in the right direction, and a negative value for a will move it in the left direction. Notice that the a goes with the x coordinate, and again our x-axis is horizontal. So right movement is positive, left movement is negative along that axis as well. With b, we notice that it goes with our y coordinate. With our y-axis, positive b will be moving upward, negative b will be moving downward. So corresponding again with the movement along that coordinate plane when we look at our x and y axes. Also noted here for a translation, we have what is referred to as vector notation. So here we've got our change only, the a and b changes, and you'll notice instead of a parentheses, we see that we have the pointed brackets here. So again, just noting the change of a and b on the coordinates in this vector notation. Our final transformation is a rotation. You'll see here we start out with our pre-image f, and if we rotate it, we end up with our image f on the right. In this example, this appears to be a 90-degree rotation. Typically, we will refer to rotations about the origin, which is the center of rotation. So if I were to mark this point here, this is the rotation point, or that center of rotation. And again, unless otherwise noted, we're referring to that point being on the coordinate plane as the origin. So recall that is 0, 0. Also, we typically, unless otherwise stated, we will be rotating in the counterclockwise direction. So when we get to our rules, we'll notice that they are counterclockwise. And this is because on our coordinate plane and our x and y axes, our quadrants are numbered in the direction of counterclockwise as well. So we see that same format when we use these rotation rules listed below. For a 90-degree rotation, we start out with our coordinates x, y. When we rotate about the origin in a counterclockwise direction, those new points will map and be transformed at the negative x or opposite, the negative of y or opposite of y, comma x. For a 180-degree rotation, we have our xy coordinate, which then transforms to the opposite of x, opposite of y coordinate. Again, more numerical examples to come in class next time. To summarize our transformations, notice that in each of these three, our initial pre-image and our image are congruent. Congruent means that those figures and shapes are the same and the same size. So same size, same shape. Again, those figures are congruent.